In this video, I'm going to be talking about an orthogonal matrix. Now, a matrix is orthogonal if the product of the original matrix and its transpose gives us an identity, right? Now, if we look at this, that if I have a matrix A, then I multiply it by its transpose, this gives me an identity matrix, right? So let's say if I have, let me use an example right now. If my original matrix is 1 out of 3 scalar, then I'm having 1, 2, negative 2, 2, 1, 2, 2, negative 2, negative 1. How will I know that this matrix is orthogonal? If its transpose multiplied by itself, the original, gives me an identity. So this one becomes an orthogonal matrix. Now let's find out. Now in this case, let's get the transpose of this. Now transposing, remember, we change rows into columns or columns into rows. Either way, it still comes out. So the transpose of this, let's transpose the original matrix. But firstly, let's say let 1 out of 3, the original matrix, to be, let's say we have 1, 2, negative 2, 2, 1, 2, 2, negative 2, negative 1. Now after assigning it that letter, that this would be A, right? Now let's transpose this. Now the transpose of A, now this will be, let's say, of A, which is the same as us having A, that this will be equal to, we're going to have something like this. This will be actually, let me not forget, you're having 1 out of 3, the scalar still comes back. Then we have the inner elements as 1, 2, negative 2. Then we're having also 2, 1, and 2. Yes. And then we're having also 2, negative 2, negative 1. So we close this, and so this is our transpose. Now the next thing that we are supposed to do is multiply this with the original matrix to see whether we come up with an identity matrix. Now let's do it. Okay, the original matrix is, we have 1 out of 3. We are going to have 1, 2, negative 2. You have 2, 1, 2, 2, negative 2, negative 1, right? Now this is the original matrix. Now we are multiplying it by a transpose, of which also the scalar comes back, right? Our transpose was 1, 2, 2. We had 1, 2, 2, then 2, 2, 1, negative 2. Then we had negative 2, 2, negative 1. Right? Now when we multiply these, we have to come back with an identity matrix. Now let's do this. If you multiply the scalars, we're going to have 1 out of 9. Let me put it this side. We're going to have 1 out of 9, right? Now let's multiply what is inside row and column. So 1 times 1, you're going to have 1. Awesome. So this is 1 times 1, we're going to have 1, right? Plus 2 times 2, you're going to get plus 4. Then negative 2 times negative 3, we are going to get positive, which is plus 4. Awesome. Now also let's do it again. Now 1 times 2, we are getting 1 times 2, we are getting 2. Awesome. Then 2 times 1, we are getting 2 plus 2. Then negative 2 times positive 2, we are getting minus 4. Awesome. Now let's also go the other side. So 1 times 2, we're getting our 2. Then 2 times negative this, we get negative 4 plus, now negative 2 times negative 1, we get 2, right? Now that is done. Now let's go to the second row. Now 2 times 1, we are getting 2 plus 1 times 2, we are getting 2. Then 2 times negative 2, we are getting negative 4. Now 2 times 2, we are getting 4. Then 1 times 1, we are getting 1. Then 2 times 2, we are getting 4, right? Positive. Then again 2 times 2, we are getting 4. Then 1 times negative 2, we are getting negative 2. Awesome. Then 2 times negative 1, we get negative 2, right? Now that one is done. Now let's go to 2 times 1. This 2 times this 1, right? We're getting 2. Then 2 times 2 plus 4. Oh, this is negative. It was 2 times 1, we got 2. Then negative 2 times 2, we're getting minus 4, right? Then negative 1 times 2, we're getting plus 2. Then 2 times 2, you're getting 4 in this case. Then negative 2 times 1, you're getting minus 2. Then negative 1 times 2, you're getting minus 2. Yes. Now let's go to the last column using the last row. Then 2 times 2, here we're having 4. Then we're having negative 2 times negative 2, we're getting positive 4 plus 4. Then negative 1 times negative 1, we are getting plus 1. Close this. Now let's work out. In this case, 1 out of 9 as my scalar. We are going to have something that 1 out of 9. Then I come here. Now 1 plus 4 plus 4, this is 9. This is 0. This is also 0, right? Now this is going to be, let's say this is 4 minus 4, this is 0. Now this is 9, right? And this is 0, right? Also, if you look at this, 2 minus 4 plus 2 is giving us a 0, right? Then 4 minus 2 minus 2, that's a 0. Then 4 plus 4 plus 1, that's a 9, right? Now let's make the 1 out of 9 go in. That means that if I multiply throughout, I'm going to have 1 0 0, and also 0 1 0, and also I'm going to have 0 0 1. And therefore we conclude that our matrix was orthogonal, because after multiplying the original matrix by the transpose, I've got an identity, right? That means that in my matrix, I multiplied the original, which was 1 out of 3. I had 1 2 negative 2 2 1 2 2 negative 2 negative 1 by its transpose, which was also 1 out of 3. From this we had, let's say, which was 1 1 2 negative 2. Then we had 2 1 2 and 2 negative 2 negative 1, which gave us an identity, which was 1 0 0 0 1 0 and 0 0 1, right? Therefore matrix A is orthogonal. That's how you confirm whether a matrix is orthogonal. And if you don't get an identity matrix, that means that matrix is not orthogonal, right? So thank you for watching. See you in the next video.